Greetings. Today we are going to discuss on the production of a specific oleochemical production that we have chose, the production of jasmine essential oil. The production of jasmine essential oil involves mainly two processes. The process will be further explained in the video later. Starting from process 1, it is divided into two steps. For process 1, it is called solvent extraction, whereby our solvent hexane will be used to extract the odoriferous substance out from the jasmine flower. For process 1B, it is called vacuum distillation. Vacuum distillation is to reduce the partial pressure of a certain mixture, thus allowing volatile component of low boiling point to be separated from the mixture. For process 2, it is also divided into two steps. The first step is alcohol extraction. Alcohol will be used to extract the aromatic principle of a material, which is what we need in our jasmine essential oil. The second step is vacuum distillation. We will start with process 1A, which is solvent extraction. As you can see right here, all of the jasmine flower will be collected and placed in a cylindrical basket perforated trays.
Concrete product with extraction is produced in static extractors, and these extractors have many perforated trays so that the flowers do not get crushed by their own weight. There is a spacer for each tray to predetermine number and distance between the tray. The perforated trays are within a removable cylindrical basket. Be careful while stacking the flowers so as to not damage it. Damaging them will cause enzymes being released in the flower juice, which reduces the quality of concrete. The basket stacked with flowers is inserted into the extractor, and the hexane is introduced from the bottom into the extractor until the material on the perforated disc assembly is completely immersed. 4 to 5 such washes are given until the material is exhausted. Now we've arrived to process 1B. The concrete extract will then flow to vacuum distillation tower, whereby the concrete is pumped into a vacuum evaporator, where the solvent is removed more carefully under high vacuum, and the recovered solvent is returned to the solvent tanks for repeated use. The resulted concrete has an odor similar to but stronger than the jasmine flower from which it was extracted. Right now, our purified concrete is done. It consists of odoriferous extract and the jasmine essential oil which we need. Right now in this diagram, process 2A, which is alcohol extraction, will be carried out. Concrete will be mixed with absolute ethyl alcohol and agitated thoroughly in the agitator. During agitation, the temperature is maintained at 40 to 60 degrees Celsius, with concrete being immersed in the solution. The solution is cooled down to -5 to -10 degrees Celsius to precipitate out the wax.
Since waxes are normally insoluble in alcohol below -1 degree Celsius, precipitation of wax will be formed. The precipitated wax is removed by passing the solution through a rotary filter. The rotary filter detailed process will be described here. Firstly, the solution is passed through the central duct. The solution will flow out to the external part of the rotary filter to the filtration zone at the bottom. As the rotary filter rotates in a clockwise direction, desired filtrate, which is ethyl alcohol and essential oil without wax, will flow from the filtration zone into another duct beside it to be collected. Before the cake, which is originally known as wax, flows through the duct, it is absorbed by the vacuum suction upon reaching up. However, the cake will not be sucked into the internal of the rotary filter, as there is another layer of filter that doesn't allow the cake to pass through due to its large size. On the contrary, the filtrate will be absorbed into the central duct as it is small enough to enter the internal of the rotary filter. At the exterior of the rotary filter, the cake will rotate along the rotary filter and get washed by the washing water. The cake will be dry again due to the strong vacuum suction from the internal of the rotary filter. All of the solvent will be sucked back inside. As the cake reaches the knife, it will be filtered and scraped off. This process repeats continuously as our filtration will be directed to another process. After the rotary filter process, we are now left with a mixture of essential oil and alcohol without the wax. We are now one step closer to the production of essential jasmine oil. Now what is left is to filter out the ethyl alcohol from the mixture. And for the final process, which is vacuum distillation, both alcohol and jasmine oil mixture will be flowed through the vacuum distillation column. The partial pressure above the liquid mixture will be lowered to be less than its usual vapor pressure due to the vapor distillation column. This will cause the absolute volatile ethyl alcohol to be evaporated easily while maintaining the delicate product of our essential jasmine oil. Once the alcohol is evaporated, jasmine oil can be collected at the bottom section of our column. And now, the collected essential jasmine oil is free from all sorts of contaminants. And that is how we collect and process to get our essential jasmine oil.
Compound extraction using supercritical carbon dioxide. Liquid carbon dioxide from a cylinder is compressed with a pump and preheated in a heat exchanger before it reaches the extraction cells. The cells are immersed in a water bath and the pressure is controlled through a back pressure regulator. The algae is placed inside the extractors and occupies only a part of them. In fact, the lower part of the extractor is filled with glass wool, which was also placed at the top of the extractor to avoid entrainment of the material extracted. After the extraction of the compounds, the carbon dioxide is expanded to atmospheric pressure through the micrometering valve, heated to the temperature of the water bath. At this pressure, the extracted compounds are practically insoluble in carbon dioxide and they are collected in the condensator.
For the safety part, firstly, I would like to talk about the fire hazard. If an azeotropic mixture is to be distilled, then ignition may be necessary if any of the fractions are flammable. Air ingress can cause flammability issues. Leaking may let in oxygen to the process, giving a flammable atmosphere or possible reaction. Normally, vacuum is let down at the end of distillation using inert gas to avoid generation of a flammable atmosphere. Residues may also be pyrophoric. Secondly, for agitator, in an agitated process, if the residue can solidify on cooling, then care should be taken to switch off agitation before solidification occurs to avoid breaking the agitator. Repeated heating of residues can lead to thermal instability due to thermal history. Malooperation upstream of the distillation, such as an overcharge of one of the components or an incomplete reaction, may affect the feed composition and consequently the thermal stability of the batch. Thermal stability screening can be carried out on materials doped with relevant materials on construction. Thirdly is the vacuum pump. If vacuum is lost during distillation, the temperature of the feed or batch can increase to the heating medium temperature. Loss of the vacuum can be due to the blockage in the line. This can in turn lead to a seal system with increasing pressure. A failing vacuum pump can have the same effect because the pump is usually sealed. This proves that sealing the vacuum pump is essential to the safety of the process. Lastly is the vacuum distillation. This consists of vacuum pumping system, allowing the later stages of distillation to take place under vacuum. The vacuum system includes a condenser cooled by brine as a vapor trap. When using a distillation column, the column design should allow for effective separation without it being liable to flooding. An undersized column will be liable to flooding, which may result in high pressure and therefore high temperature in the still. Flooding will also affect separation and can result in delay problems such as water-solvent separation in reactive distillations. Compatibility of materials of construction is particularly important as there are an increased surface area in column packing. Corrosion products from the column packing may catalyze decomposition or reaction on the column.